Good afternoon, dear participants of the conference. Let me introduce the authors team of our research. Olga Kuzmenko, Doctor of Pedagogical Sciences, Associate Professor. Marina Rostoka, PhD of Pedagogical Sciences, Senior Researcher. Gennady Cherevichny, PhD of Historical Sciences, Associate Professor. Sergei Zubin, Doctor of Engineering Sciences, Professor. The subject of our research, modeling of eco-environment of information analytical systems for training of scientific personnel based on e-learning. The goals of the Ukraine educational are integrated into the world scientific and educational space, reproduction and strengthening of the intellectual potential of state, including scientific training and ensuring the comprehensive development of scientific personnel based on the formation of soft skills specialists in popular professions. Important factors in the formation of a modern educational system in the 21st century are requires from stakeholders, integration in the world educational space, reproduction and strengthening of the intellectual potential of the state, integration in the world educational space, transdisciplinarity, eco-environment of information analytical systems, development of e-learning and learning tools, elements of virtual and augmented reality. Theory and practice of innovative activities reflected in eco-environment modeling. The trend of spreading innovations is that educational absorbs innovations and changes only partially, structurally, functionally, and substantively. Innovation is not always realized, which is influenced by social, political, economic, psychological, pedagogical, and other factors. The emergence of innovation is associated with transformations in society, reforms, progressive movements. In our research, the authors considered the genesis of the development of innovative models of education, which influence the rationale for the creation of innovative modeling of the eco-environment information and analytical systems. And in this slide you see some structures, models that we use in our research and analyze some aspects of these traditional models. Methodology and concepts of creating the eco-environment of the information and analytical system. The study aims to substantiate the theoretical and practical aspects of modeling the eco-environment of information and analytical system of scientific training using e-learning technologies and develop methods for its implementation in the educational process, taking into account current trends in Industry 4.0. The objects of research in the process of modeling the eco-environment of the information analytical system of scientific training based on e-learning. The subject of the research is models, methods and software of eco-environment of the informational analytical system of scientific personnel training in the content of e-learning. The concepts of the study in the formation and development of hard and soft skills in the future researchers in the educational process of higher educational institutes to model the eco-environment of the informational analytical systems based on e-learning, which is required to obtain certain indicators. The main idea of the study is to state that the formation and development of soft skills in future research specialists are based on the principles of fundamentalization as well as taking into account transdisciplinary competency and systematic approaches that provide learning guidelines to solve educational problems required for the training in the professional field. We have our vision for determining the specific pedagogical goals of modeling innovation eco-information analytical systems in higher and scientific research institutions for the training and scientific personnel, namely intensification of the scientific and educational process, increasing its efficiency and quality in the teaching of software engineering, natural sciences, and other technical disciplines. Implementation of the social order conditioned by the information of modern society, etc. Training of scientific personnel in this subject area and training of users using e-learning technologies, in particular in the field of STEM education. Development of the creative potential of science, for example, including abilities to communicative action, skills of experimental research activeness, through the use of e-learning technology, which is the integral part of the development of transdisciplinary component in educational, vocational educational, for example, STEM education. And the structure of our research model you see in this slide. We propose the components of Ecoenvironment model and information analytical systems, research subject component, material and technical components, the ideological and technological components. Ecoenvironment information and analytical system model and functions. Identification, disclosure and development of abilities and potential opportunities of students for creative initiatives. Creation of conditions for the independent acquisition of knowledge and their quality assimilation, providing automation of learning outcomes, process based on e-learning tools. Diagnostics, management and forecasting of individual achievements of students in the eco-environment. Examples of using e-learning in teaching physics and technical disciplines. Using SolidWorks as an aircraft modeling tool, and use their myoelectric in the field of neuroprosthetics. The reliability and validity of the research results are ensured by the compliance of the main provisions with the leading directions and the level of development of innovative trends in model in the innovation eco-environment information analytical systems, confirmed by the positive result of the scientific and pedagogical experiment, competence and statistical significance of empirical material, through analysis, active discussion of the results of the wide range of participants in scientific and practical activities using innovative technologies and testing methods of teaching academic disciplines on the basis of e-learning. The total number of participants in the experimental study is 327 respondents, of whom 157 applicants of science education control groups and 170 applicants for science education experimental group. And you see for some change dynamic from scientific groups and control group in this slide. It's the dynamics of the quality indicators of the achievements of the applicants for science education in the implementation of the methodology of science and educational activities in the innovation eco-environment information analytical systems. Conclusion. It was found that the development of innovative trends in science and education affects and needs of the labor market, in particular in the training of scientific personnel in the technical field. Therefore, in the course of the research, the authors found the expediency of taking into account psychological and pedagogical factors of formation of in eco EIS, K and CRI in the process of modeling in eco EIS should pay attention to the compliance of its component structure and functioning of general pedagogical principles considered in the works of various authors and which should be taken into account in any social pedagogical systems based on system modeling and fundamentalization disciplines in software engineering, including physics and professionally oriented disciplines. The application of the principle of fundamentalization of education in the context of specialization of a professional in defining the principle of scientificness involves the acquisition of certain competencies and actually forming each subject of learning personal knowledge system endowed with properties of depth, integrity, universality has a fundamental basis development of innovative education taken into account e-learning. Involvement of the principle of excellence in modeling and construction of in eco-EAS training of scientific personnel consists in ensuring technological orientation and structural compliance of information scientific and educational environment with the tasks of the open social pedagogical systems. Application of the principles of innovation which relies through the ability to order and pay for the supply of STEM technology and e-learning tools as they are used which significantly increase the freedom of choice and experimentation with different types of tools, electronic resources, software, compact platforms and technologies. Expand the share of research approach in the teaching of IT disciplines, including physics, promote the development of skills of joint processing and analysis of data and results of collective study of phenomena and processes. The report is over. Thank you for your attention.